Under the watchful eye of the Defense Advanced Research Projects Agency, an extraordinary creation has been taking shape. A remarkable aircraft that emerged as the culmination of groundbreaking innovation. The new unmanned aerial vehicle, designated X-65, after a long line of iconic experimental aircraft, will ditch all traditional control surfaces that had limited aerodynamics for generations. Instead, it will find control from within. The X-65 will feature active flow control rather than passive exterior moving controls, and redefine aviation with compressed air nozzles to execute maneuvers, subverting long-held tenets of aviation and aerodynamics. The advances expected from this project seem taken out of a science fiction story. They could usher in a new era of reduced radar cross-sections, increased maneuverability, and unparalleled efficiency in flight. Besides drones, this technology would make fighter aircraft more agile and commercial passenger airliners more environmentally friendly. As of 2023, an aviation giant has just taken up the task of bringing this outstanding piece of engineering to life. Pushing the envelope. DARPA, known for its avant-garde exploration of advanced technologies on behalf of the Pentagon, recently unveiled a revolutionary drone technology demonstrator. The pioneering project aimed to test the capabilities of active flow control systems, or AFC. Such systems promised to enhance fuel efficiency while reducing radar signatures, all achieved by allowing for a more streamlined and aerodynamic aircraft configuration. The experimental nature of this uncrewed marvel became evident as it discarded the conventional flight controls that had long governed aerodynamic design. Instead, banks of compressed air nozzles were employed to execute awe-inspiring maneuvers without the need for traditional exterior moving flight controls like hinged flaps, rudders, ailerons, elevators, and spoilers. These control surfaces, although effective throughout the history of aviation, brought along the burden of added weight and intricate complexities. Capturing the imagination of aviation enthusiasts and experts alike, DARPA took to its social media platforms to proudly announce the coveted X designation bestowed upon this leading-edge creation. This significant milestone came just shy of 5 months after DARPA's selection of Aurora Flight Sciences, a subsidiary of Boeing, to embark on the detailed design phase of the Control of Revolutionary Aircraft with Novel Effectors program, or CRANE. A national asset. DARPA chose Aurora Flight Sciences to proceed with the CRANE program to create an aircraft that can fly without traditional moving flight controls on its wings and tail. In turn, Aurora successfully completed Phase 1, which involved designing a testbed aircraft that utilized AFC in a wind tunnel. Phase 1 involved wind tunnel testing on a scaled-down version of the X-65 prototype, using compressed air blasting and suctioning nozzle arrays on the wing's upper surface. The next phase aims to test the technology at mission-relevant scale and Mach numbers. Phase 2 will not only assess the craft's supersonic flight capabilities, but will also focus on the detailed design and development of flight software and controls, leading to a critical design review of an X-plane demonstrator. The contract also includes a Phase 3 option, in which DARPA plans to fly a 7,000-pound X-plane that addresses the main technical challenges of incorporating AFC into a full-scale aircraft and relying on it for controlled flight. The demonstrator aircraft will feature modular wing configurations to facilitate the integration of advanced technologies for future flight testing. The company is confident in completing the AFC-based demonstration aircraft's design and flight testing, which would become a national test asset beyond the CRANE program. However, the current aircraft under construction is expected to achieve a maximum speed of Mach 0.7, barely 537 miles per hour, and it is not scheduled for testing until 2025. Out of this world. DARPA recently unveiled art concepts for the X-65. Interestingly, commentators have pointed out that, as described by DARPA, the aircraft resembles the fictional X-Wing starfighter from Star Wars when viewed from the front. This is due to its canted double wings, although the similarity is less apparent from other angles. The designation of the X-65 may even be a nod to the T-65 model of the X-Wing in Star Wars lore. Unlike traditional aircraft, the experimental type has a revolutionary active flow control system that promises improved maneuverability and control. By eliminating traditional jointed surfaces, This innovative design could enhance flight performance while reducing costs and wear and tear. It could also, theoretically, improve the aircraft's stealth capabilities. The AFC system offers numerous advantages. It eliminates the need for moving control surfaces, resulting in reduced drag and improved flight at high angles of attack. Based on the available pictures, it appears that the X-65 will be powered by a single jet engine with an intake located under the belly. Additionally, there seems to be an upper fuselage intake and exhaust, potentially used to generate compressed air for use in the 14 nozzle banks around the airframe. On the other hand, DARPA emphasized the inclusion of modular wing configurations, allowing for the integration of advanced technologies in future flight testing. The X-65's design will be highly modular, enabling the swapping of different wings with varying degrees of sweep and different types of AFC effectuators, including those developed by other companies. The X-65 represents a groundbreaking leap in flight control technology, capturing the imagination of aviation enthusiasts and showcasing the exciting possibilities for the future of flight. The potential. Active flow control is a technique used in aircraft to manipulate the airflow and improve performance. Unlike passive features, such as vortex generators, that affect airflow permanently, AFC utilizes nozzles to release jets of air that dynamically alter the pressure of the boundary air around the craft. Besides compressed air, other methods of manipulating the airflow, like plasma effectors, are being studied. Its main objective, eliminating surfaces on the aircraft that cause drag and increase radar signature, is particularly crucial for military aircraft, including drones. Operating in contested airspace, monitored by advanced radar-guided missile defenses, requires stealth. Reducing the radar cross-section is essential, even for non-combat aircraft, like tankers and transports. The B-2 stealth bombers address these challenges through complex flight control systems that manipulate flaps for stability and turning while discarding the tail fin and rudder control surface. However, even these reduced movements increase the radar cross-section. AFC has the potential to render this vulnerability unnecessary in future aircraft. Moreover, reducing drag is significant for civilian aircraft operators as well. Improved fuel efficiency and extended range are highly desirable outcomes. Airlines can reduce pollution and save substantial fuel costs with even a slight increase in fuel efficiency. Likewise, military aircraft, including jets, drones, and missiles, can travel farther with the same fuel load. Eventually, AFC nozzle arrays are expected to become lighter, less complex, and more fuel efficient than traditional moving control surfaces. Heritage. During NATO's 2018 tests, drones equipped with AFC responded more aggressively than anticipated, showcasing their agility. If these systems can deliver high performance while maintaining low weight, complexity, and radar cross-section, they could be attractive for various aircraft, including modern jet fighters. Projects like Crane are working toward making AFC technology affordable and practical for widespread adoption. The program's manager, Richard Lezian, stated that the X-65 would probably benefit a variety of other airflow control experiments, hypothetically including those of BAE Systems' Magma drone. Welcome to Dark Tech. We're thrilled that you're here. Don't miss out on the chance to delve deeper into our captivating stories. Give that like button a click and subscribe to this channel and the rest of our Dark Documentaries family. By doing so, you'll stay ahead of the curve and be the first to hear about our thrilling upcoming releases. Thank you for tuning in.